Hello, welcome to the Data Channel. So today we are excited to bring a new set of playlist actually, and so this playlist is about the system design. So there are a lot of system design related concepts as a data engineer you need to understand. So as part of this playlist, we will be bringing a series of videos. So and as part of the first video, we will be discussing about APIs for data engineers and so what exactly as a data engineers we need to understand from the different concepts in API, right? And imagine you have just joined a new data engineering team, and your first task is to create a data pipeline that pulls leads from Salesforce or campaign metrics from Google Ads or daily sales from Shopify, or maybe even stock market prices from a financial or a trading API, right? So that might be your task. Okay, so that is why it is very important to understand APIs. Okay, so now none of these platforms are going to email you the CSVs every day, or they will not give you the database where you can go and pull the data, or they are not giving you the data warehouse or the file system where you can just go and pull the data from. So they all expose their data in through something called as APIs, right? And as a data engineers, APIs are your lifeline. So they are the invisible connectors that let you talk to the external systems and bring the structured data into your pipelines and even control your cloud infrastructure as well. And in this particular video, we are going to take a deep dive into APIs specifically for data engineers, and we'll be covering a couple of topics. So what topics we'll be covering, we'll see that. Before proceeding, if you're new to this channel, we would recommend you to please subscribe and also press bell button for instant notification. So let's get started. So in this video, we'll be discussing about what APIs are and why actually they matter for the data engineers, and what are different types of APIs you might encounter, and how the request response cycle works, right? And how the authentication works in APIs, and what are the different practices as a data engineer you need to follow to build a production grade pipelines using integrating with APIs. And also we will see certain real world use cases you will actually see on the job, right? The similar real world use cases we will see. So that is why by end of this video you'll not only understand APIs at the high level, but also you will also know how to put them together into the practice your everyday data engineering in the everyday data engineering work. So that is why please stay till end of this video, and so that you can get maximum out of it, right? So moving on, basically we will take this and understand what exactly is an API. So let's start from the very beginning, right? So what is API? So API is like the simplest analogy you can take is a restaurant, your restaurant menu, right? So when you walk into a restaurant, you don't barge into a kitchen and start cooking, right? So instead you look at a menu, so you pick what you want, and you place an order. Then kitchen starts preparing your dish and serves it. So now imagine the kitchen as a software system, and the menu is like a API, right? You don't see the kitchen, how the kitchen is run. You don't care about the recipes, how it is being cooked. All you need is what you ordered, so the food, and you just need to receive it, right? So that is what it matters to you. So that's what a API does. So in an interface that allows APIs, and in like interface it allows one software to interact with another. Okay, and typically like it will be like a request response, right? So more formally, an API, short for an application program interface, is a set of rules basically. That is why that is a more formal definition of API is a set of rules and protocols that define how different software components should communicate with each other. So that is what the API formally means. Okay, and this is an analogy that we have seen, and so for data engineers this is critical. Okay, why it is critical? Because the companies rarely give you raw database access. So instead they expose like API, so you can fetch data safely and securely. So APIs basically abstract the complexity of the internal systems. For example, when you use a Salesforce API, you don't need to know their internal databases, schemas, or architecture, right? The API makes it possible to standardize the communication across thousands of different services. So you might be one of the services that is using, but the Salesforce might be exposing the same kind of API to the different kinds of customers, right? Whether you're dealing with the finance, marketing, IoT, or even cloud automation, APIs gives you a common language. So it actually, that is the one of the advantage of API, because it is standardizing the responses based on the requests, based on the request. So many customers can leverage because of that standardization. So whenever you think of an API, think it is as a contract between two systems, right? You make a request, follow the rules of the contract, and you get a response back. So that's the what exactly API is. And now, interestingly, we will see why API matters for data engineers. Okay, so this is what we need to understand, right? Because this is, you might be curious. Okay, this is what API is, but what I'm going to get out of the APIs, and what is my day-to-day routine, and how API will matter to me in my day-to-day operations or day-to-day activities, right? So first, let's take about data ingestion. So this is probably the number one reason data engineers interact with the APIs. Like modern business generate a lot of data across countless and different platforms, like CRMs, like Salesforce, ad platforms like Google Ads, e-commerce systems like Shopify, and you can talk about like ticketing tool like Jira. So almost all of them exposes an API. So you can pull their data into the data lake or the data warehouse. So without APIs, you would be stuck manually downloading the CSVs, and that just that you cannot just scale that. Or you might be using their database, connecting directly to their database and pulling the data, or you might be connecting to their data lake and pulling the data. So that is not a scalable, secure way of exposing the data, right? So that is why the data ingestion, when you're doing it, so if you want to have the scalability and more secure way of connecting to the different source system, so that is where the data ingestion, where what we are doing. So the APIs are plays a critical role here, right? And the next is streaming, that is real-time streaming, right? So APIs aren't just about the static data pulls. So you might think, okay, APIs isn't just nothing but like what I do is I'll send a request and I'll get a response. So that is more of a static pulls, right? It might be push or pull. But some APIs provides event streams or push data in real time. So think of IoT sensors sending weather data, or a Twitter streaming API sending live tweets. For data engineers, this is gold actually when you're building streaming pipelines using Kafka, Spark Streaming, or Flink. Okay. I'll take one more example, like where real-time streaming comes into picture, right? You like where you are having a retail platform, and data is there's a transactions going on, right? Because customers are placing the orders, and you are having a Kafka based APIs where you are receiving that data continuously from the source system as and when the orders are placed, so in real time, so that you are consuming from the APIs, right? So that is also Kafka, like using a Kafka pipeline. So that is also a API, because there is a certain kind of mechanism and like authentication mechanism and how API works, right? So that is also a use case. And also the automation part of it. So automation and orchestration, right? So here what happens is APIs are not just about reading the data, and they are also about controlling the systems, right? Like definitely we send a request, we get a response. So that is a primary requirement, right? But it's not just about that. So they are also controlling the systems. For example, as a data engineer, you might use the data like Databricks REST API to like trigger a Spark job, scale up the cluster, monitor the job, or you might use AWS API. So like also, and you can spin up the S3 bucket, manage IAM roles, launch EC2 instances. Everything can be automated. Like these are most of the things. What I'm talking about is system admin activities or network administration activities, or SRE related activities, right? So all of this automation, what you can think of, can be done, or we can leverage the APIs to perform these kind of automation. So this is where we're talking about robotic automations, right? So you can even use there so to automate your day-to-day routine operations. Okay, so these are the things where you can think of from the operational lens in the production scenario, where you want to apply some patches, monitor some jobs, and scale up the cluster automatically, etc. Right? So all of these things can be done using a certain APIs by kind of monitoring it and automatically scaling up the cluster based on the memory, etc. All this can be done using automation, can be done using the APIs. And also orchestration. So whether you are using a Airflow, Prefect, ADF, Data Factory, APIs happening in the background. Okay, Airflow operates like a HTTP sensor or a simple HTTP operator directly interacting with the APIs to check status, fetch data, or trigger the jobs. So you might be using a pipeline, right? So like Data Factory also, Data Factory is pulling the data, but behind the scene, the implementation of this Data Factory or Airflow or Prefect, so all of these tools is actually behind the scenes. It is using APIs. So APIs aren't just a side tool. So they are actually at the core of the data engineering pipelines, whether you're automating workflows or integrating different systems, right? So that those are very critical. So now let's move on to the types of APIs. All right. Let's break down the different types that you can think of APIs, and you might come across these. So first thing is the REST APIs. So these are very commonly used, okay, and these are very commonly used, and also like most people would be aware of REST APIs. So REST means REST representation state transfer. So these basically these are by far the most commonly used, as we said, and they use standard HTTP method like get, post, put, delete kind of HTTP methods. They usually return JSON, so their output you can see it will be in a JSON format, and but sometimes it might be XML also in some cases, but mostly it will be JSON. For example, you might fetch leads data from Salesforce, right? REST API. So that's example. And as a data engineer, you will see REST APIs almost every integration. We will be using REST API from marketing platforms to financial APIs, right? So mostly the REST APIs are used, and this is very most widely used. If you talk about all of these four different APIs, REST API is most widely used. So now let's see the SOAP API. SOAP API is like simple access protocol, simple object access protocol. So this is a kind of a legacy, that older XML based, and it's more verbose, harder to work with, but still very common in certain enterprises and banking system where still the legacy systems are used. Example, a payment gateway in an older banking system might still expose a SOAP API. Right? And so next is a GraphQL API. So much more modern. Instead of rigid endpoints, you can query exactly what you want. So basically, it helps reducing overfetching or underfetching. Okay, you can control that. So example, GitHub's Graph API let you fetch repository data with just one query instead of hitting multiple REST endpoints. And GraphQL is becoming more popular for analytics because you can optimize the payloads. There is an option to do that. So because you have that option, it is becoming more popular in analytics scenarios. And the next is streaming APIs. So streaming APIs that we were discussing in the previous slide, right? So similarly, like it is one of the, we can consider as a type of API, provide real-time updates, often over WebSockets or long polling. So if you want to avoid long polling or WebSocket kind of scenarios. So like example, Twitter streaming API delivers tweets as they are published. And another example you can think of is financial exchanges provide market tickets like tickers in real time via streaming APIs. And again, as a data engineers, you will need to be comfortable working with all of these four. So REST and Graph API These two, basically REST API and GraphQL API, will cover 80% of the use cases. But don't ignore SOAP and streaming. So we might be using rarely, but they still show up in some production scenarios. But definitely Graph API and REST APIs. This is very important. So with that, we will move to the next slide. So here we'll understand how APIs work, right? Whenever you call an API, so you are following a request response cycle. That means you hit an endpoint. For example, this is like an endpoint, right? api.twitter.com/tweets. And you specify HTTP method, whether you want to use get to fetch data, post to insert the data, and put to update, and delete to remove. Okay. So, and based on that methods, and also you need to include the headers. So things like authentication tokens, content type, or request IDs will be part of header. And then you have something called as a, like, you may send a payload. Usually it will be in a JSON format, and the response back with the status code and the response body. So here what we are doing is we are as a client, right? So we send a request to the API, and API will get us the response, right? It is simple request and response kind of a protocol. But when we are doing that request, so these are certain rules we need to follow. That means you need to have a header. We need to specify what method you are like preferring, right? And there'll be something called as body or payload, right? So these kind of things you need to follow when you are requesting it. And the API is responsible of going internally, and it is like, as I said, like it is like a internally, like there will be a chef who will be preparing all this data. That means there will be a server who is preparing all this data, maybe database who is having this data that is being transformed. But ultimately, the API is where works as like a postman, or postman who brings this data into the requested client as a response. And once you get the response, it is not just about the data. So you're not getting data as a response. Along with that, you get a status also. So there is different status codes, like to understand whether the request that is being received is successful, or it is having some failure. If it is failure, whether it is a client level failure or server level failure, or it might be any kind of different error codes. Based on the error codes, you will be able to identify what kind of error that might have occurred. Okay. And this is like a super simple example of Python using a request library. So if you're using Python, so this Python has this request library, and in this basically this is calling this hits the Coinbit CoinDesk Bitcoin price index API, and it print out the current Bitcoin price in the JSON format. Okay, that's what it is simply doing. And even you can like say print response.status code, so that it will print the status code. And you can even print the, say, print response.headers, or print response.json. So what we are doing, so the response.json is giving you JSON is a structure, so it is easy for us to transform into a data frame later. This is where the data has been received. So we are getting three different things, right? So one is the header, one is the status code, which will specify what exactly happened. Status code also are important. Like if you have 200, that 200 as a status code, that means it is success. 404 means not found, and 500 series is mostly for the, like, if there is any server related errors. And header often includes rate limiting informations, and JSON is actually where your data is. So that is why you need to capture this JSON response.json into like a make it in a structure, or convert it to data frame, so that you can perform different kind of transformation on top of this data. So this is basically what we need to understand. It's just like a simple request and response cycle. And this is the foundation of all API, how it works. And no matter how complex these APIs are, but it's all about request and response. So with that, we will move to the next slide and understand authentications in APIs. Most real world APIs aren't public. Okay. So they don't expose it for everyone. So they require authentication to make sure only authorized client can access. So that is where, like if you make everything public, so there are definitely few public APIs which are available where you can, especially from Google and a few from like some trading related, weather related APIs might be available. But generally, it will be having some cost, right, associated with consuming the API. So if you want to subscribe to a API of a Twitter or API of a particular banking system or API of any trading system to get a Forex information, so then you have to subscribe to that API by paying certain amount, right, or getting subscribed to that API, right? And once you have the subscription or you have authorization as a client, so you'll be getting certain authorization related details, whether it might be in the form of API keys, like they might provide you the password. So, and that password you can use to send it in a header so that you are authenticating or authorizing yourself, right, as a legitimate user, right, before you send a request. Okay, it's like a password you are sending, and it is simple but not super secure, because password is not a it's a rudimentary way of using authentication, right? It is not so secure or safe. So that is why you have OAuth authentication, OAuth 2. So which is a very widely used in nowadays because it's much more secure, and it is more common in Google, Facebook, LinkedIn APIs as well, and involves an authorization flow where you log in and grant permission and you get a token and return. So it is API keys is a one-way handshake, right? You just send a key and a request and you get a response. But OAuth authentication is a multi-layered handshake. Basically, first you send a request with the OAuth token, right? And you get a temporary token. OAuth, you will pass a OAuth and you get a temporary token from the client, the server, or whoever you are requesting the API with, and using that token, you again send a request. So that is where it's a two-way, okay, two-way authentication. So and it's more secure way of doing it, right? And it was like a two-way authentication. Okay. So other one is like JWT, JSON Web Tokens. So this is like encoded token containing claims about users, and it is stateless. Okay. So they do not have to be stored in any server, and common in microservices architecture. If you are working in microservices architecture, then this JWT API is most commonly used. But generally, if you take OAuth authentication is most widely used in APIs, especially if you talk about REST APIs, because those are now mostly used. And for the data engineer, this matters because you will need to build a pipeline, right? Ultimately, that refreshes the token, store credentials securely, and handle the re-authentication automatically, because passwords might fail or password might expire, and it might not be if you're storing it in plain text. All those risks are there. But OAuth is not like that, because it's like every request you are getting a token with the expiry. So that comes with the expiry, right? So you can use that safely and securely. So that's the thing. And so with that, we will move to the next slide. So where we're talking about the few of the topics as a best practice for data engineers. So this again, if you are looking for any interviews, or if you are just generally want to understand as a data engineers, what are the a few things that I need to take care of, right? So these are the checkpoints you can take notes. So first thing is a retry failed calls. That means APIs can fail due to network glitches or any other different issues, right? Always implement retries with exponential backoff. That means you need to, like, if you are trying to hit an API or API server or API, so there might be cases where it is having network glitch, or because of a lot of request it is failing. So in that case, you need to have some retry mechanism with certain frequency, okay, to that to so that you can have that back off, okay, with that failures. And also handle rate limiting. That means many APIs cap the requests. Say for example, like 1,000 per day or 10,000 per day or 500 per hour. So always respect the 429 error scenarios and add wait time. So if any limiting APIs are limiting your requests, or if there's too many requests, sometimes you see a message, right? Too many requests, for not 429, too many requests, right? So that is where you need to have that kind of, like, if you need to monitor this, right? If you are getting certain 429 kind of error, so you need to have certain logic to add like wait conditions. So to wait for a certain period and then retry after that. And idempotency. That means if your pipeline retries a post call, make sure it doesn't insert duplicates. Idempotency is nothing but generally what it means is a same code executed multiple times have a same impact. That means even though you are calling a post method multiple times, so it should not insert duplicates or post or put method, right? Especially get doesn't have any problem because you're just getting the data. But when you talk about post or put, so you need to make sure that it is not inserting the duplicate values. So user request IDs, or you can use request IDs or deduplication strategies to handle this, so that you don't have any duplicate kind of issues by using this API. So this is very, again, one of the most commonly encountered challenge in APIs. And other challenge is like pagination. So it's not a challenge, but it is a solution, okay, for a challenge. That means APIs often results in page. Why it results in page? Because there might be huge amount of data which might not fit in the one response. Okay, if you are hitting an API, it might, the records might be 10,000 records, right, or 1,000 records, and it might not put all these 1,000 records and send it as one response. So generally in that case, you need to implement something called as pagination. So like, again, you can control that pagination. So pagination is nothing but in one response, how much records you want to receive. So whether you want to receive like 100 records in one payload, like a response payload, or 10 records, and you need to mention the offset, how many offset you want to have, so that you want to fetch the full data sets. So that is a pagination. So that's about pagination. And so you have a schema validation or schema enforcement. So APIs change, right? Like columns can disappear or new fields can get added. So always we need to validate the schema and any log mismatches, so that you can handle that gracefully in the production scenario if you encounter that. And there is logging and monitoring. So if an API fails, say for example at 2 a.m., your entire pipeline could break. So always log status codes and set up alerts so that you can come back and see what has happened at that midnight. Okay. So that is where, like, how do like, similarly, how you kind of log and monitor the like batch processing of the data. Similarly, you need to have the entire pipeline monitoring for the API. So API monitoring is little tricky because so it generally comes up with a lot of it's a request response, right? You need to be very careful when you're capturing the response requests. So you need to capture the error code, and there is not much about the debugging here, right? So it might just sometimes give the error code, and based on the error code, you need to go back and see what has happened. Another thing is you need to make sure that the data which is lost, okay, because sometimes if API doesn't give the API might not give the entire story what has happened, right? And you need to sometimes backfill the data which has been lost. So to backfill the data, you need to understand how much of data was lost, etc. So that is why monitoring, logging, and auditing is very critical in terms of like APIs when you are using them, right? And like any data triaging issues also, if you want to like see what has happened and kind of perform root cause analysis of that, so you need to have this monitoring and logging maintained. So with that, we will see now the real world use cases, right? So as a data engineers, like there are, like, you might encounter these scenarios working in different projects specific to marketing. So like APIs like Google Ads, Facebook Ads, or HubSpot to fetch ad performance metrics. So that is like a marketing, right? So you can have something called as in finance space, Like there are APIs like Bloomberg, Apple Vantage, or CoinDesk for Bitcoin, right, to pull market data. So again, it depends on like there are different APIs that's specific to the marketing, finance, and SaaS. Okay, SaaS application. If you take like Salesforce exposes its API so that you can use that API to fetch customer leads, and there is Zendex API for ticketing data, so you can use that to get that informations. And even the cloud, right? If you take about Azure, AWS also have their own APIs to manage the infrastructures, and Databricks REST APIs for triggering Spark jobs. And you can use Databricks Delta. You can pull the data from the Databricks using Delta Live tables, right? Using the API concepts and the Delta sharing concept. And you also have the public data set. So this doesn't have any authentications mostly. And like these will be usually like weather data and any government or public sector APIs, maybe for census, weather related data. So you can get it from the public data sets. And you can generally use this public data set if you are learning something, right? So you can use this public data set, which are readily available, public data set APIs, and you can experiment, or you can kind of understand how API works using this public data sets. So, with that, we will move to the small case study. That means a small code. We will see how exactly the code looks for this. And the choice of programming here is the Python, right? And we are going to we are going to fetch a Bitcoin price from the CoinDesk API. And then we are kind of transforming the data into a clean structure and then saving that into a CSV format. So here, if you see, this is a request, like import request. It's a Python library, and then you are using pandas. We will see why we are using pandas here to convert the data frame. We are using pandas here, and we are using datetime to kind of perform some date related formatting here. And this is the API, right? So this is how the API looks like. So this is like https slash something dot com, and then so we have v1 slash bpi slash. So this is the, so here you see slash bpi slash current price dot json, right? So there might be certain parameters also. You might be passing here, you're just passing the absolute URL, and along with that absolute URL, you might be passing like question mark parameters, right? So like you can put some filters, basically current price, like you can give a country, you can give certain customer IDs, right? When you are calling that API, you can kind of apply those filters if API is facilitating that. So sometimes if you're not specifying anything, so API might give you the entire data set as a response, which is eligible for this particular API, right? So, and next step is where you are making the API call. That means you are using request.get. So get is a method. So you can use post, put, etc., delete, etc., right? So you want to get something out of using this API now, and that is stored in the response. And then you are doing a response.json. That means you're converting that into a JSON format and putting into a data as a variable here. And then, so because now you have the data stored in the variable, so what we are doing is we will start the transformation, right? So this is how record equals to, you are giving like this is how the transformation look like, where you are transforming the like timestamp currency to USD and price to something, right? You are doing some kind of transformation here. And then finally what you will do is you're converting to data frame. So here, like you are using pandas to convert that response that you got into a data frame. So p dot data frame, and you are passing this record. Okay, and you finally will get a data frame. And this data frame you are converting to CSV, because ultimately I want to convert the JSON to a CSV format, because CSV is more like a columnar, like it has a columns and rows, right? It is like a tabular format. So that is where ultimately I want to convert it to CSV. You can convert it to a Parquet, you can convert it to a different file formats, right? It is the option of your choice. It's your choice basically, and then you are printing to see the data is saved successfully. So this is how you are actually fetching the data from the Bitcoin API. So to see the prices, and this is the CoinDesk API that Bitcoin exposes, and then you're transforming that data and finally saving it to a CSV format. So this is how it looks like. So this is a public API, but if you talk about the private APIs or closed APIs, so generally you will have one more step here where you're authenticating, right? Like I was talking about the request OAuth authentication. So there will be, before making a call, you will have one more step where you are getting a token. So once you get a token, and that token you will be passing again to make another call where you actually get the response back. Okay, so that's the difference we'll be seeing. So after you save the data into CSV format, so from here you might be using it in a putting in a data lake or database, or you might be exposing it to Power BI, triggering alerts if the prices cross a threshold, or even feed it to a like a trading model. So you can do a lot of operations, right? This is the power of APIs. So turning live data into a actionable pipelines. So we will see like one of the sample request response, how it looks like. So you see a request here, right? So this is a sample request. You might be passing prospect ID, name, email ID, phone number, and all these things. So for this particular parameters, so it you are using this parameter. This is a payload actually, right? And along with this payload, actually you will be having header, right? You'll be having certain, this is not how exactly it's not a full, this is a payload part of the request. And then again, you might be having header and other parameters. And then you will be passing this as a sample request. So sample response would look like as a, this is output JSON, how the sample response might look like. So here you will be seeing the actual data. Definitely you will see lead ID, received at ingestion pipeline. What was the ingestion pipeline? So this is the lead ID is what we are looking as a data, but there might be other like what is the status and what is the message. So you can have many custom messages along with the data. So as it depends on how the response of that API is built. Okay. So this is simple like simple request and response, but the response might be this is one, right? But if the response is having like say 10 records, it will be having so this is one JSON and then comma another JSON and then comma another JSON. So it will be a series of JSON, and sometimes the response might be a nested JSON also in some rare cases, but generally it will be a like a flat JSON like this. This is one record. Similarly, you will have multiple records as a comma separated. So with that, we will move to the end of the video. That is to conclude this. Basically, to summarize, APIs are the backbone of modern data engineering, and they let you ingest the data from different countless external platforms, automate the workflows, or help in orchestration, and also help in build streaming and real-time pipelines as well. And we have covered what APIs are, why they matter, and there are different types of API, how they actually work, what are the authentication mechanism, best practices, real world use cases, and even we have seen a sample code, how exactly a pipeline or a code look like. So like hope this was useful, and if this is useful, please like, share, and subscribe, and also press bell button for instant notification. Thanks for watching.